Hey there, welcome back to Coding at Home. Hey there, I'm Matt. Welcome back to Coding at Home with the Code Hub. Today we are going to be going back to our Sensor Arcade playground. We've been having fun all last week working with the different sensors on the iPad. We worked with the camera to get the light sensor, and we could kind of use the light to determine how big or small our character got. We used things like the microphone on Friday, where we played around with the sound a little bit, and we used the pitch to determine when certain rockets, or not rockets, but poppers would go up and pop balloons, and we tried to avoid the bombs. Hopefully you played around with that a little bit this weekend and figured out maybe a good way to solve it consistently and to win the game. My time wasn't great. Hopefully you beat my time. So what we're going to do now, though, we also played around with touch, of course, where we were touching on the screen and moving around a player according to where we touched, and we were able to capture cupcakes. So today's is kind of similar. We're going to go back to sort of on-device, on-screen type of events that we're going to be capturing, because all of this stuff that we've been doing has been dealing with events. That's what we were told about as soon as we opened up this playground. It said we're going to write event handlers. So anytime an event like the light gets updated, or the touch position gets updated on the screen, or we hear a different tone coming in through the microphone, we're going to get an update and we'll react to that. Today, we're going to get events that are triggered when two virtual objects on our iPad collide. And we're going to use a framework called SpriteKit. So if you were ever thinking of developing a game, especially one that's 2D, Apple has a really nice framework called SpriteKit, where your different objects on the screen are called sprites, and they have lots of different properties attached to them. They can have physics attached to them, so you can apply impulses and force, and we've seen that in some of the prior pages. And then you can also do things like have it react to gravity. And we saw that a little bit when we were playing with Reality Composer a couple weeks ago. So today's thing is going to be all about collisions. So let's dive over to the iPad and take a look. All right, so here we go. So this is where we were on Friday. We had a big chunk of code where we varied which popper would get an impulse applied to it just on the y-axis, so it would go up and down when it heard a certain tone of a certain pitch. So that was our work on Friday. I hope you played around with this a little bit more. They had a solution in the hints, you remember, where they did a bit of math based on the pitch to figure out which popper they wanted to rise or lower. That would have been a lot less code than this code that we wrote here. But sometimes you have to write the long version of the code first to get to the shorter version. So today we're going to tap on the arrow and go over to Bumper Bash. And so the goal here is to score more points in the game. And we need to edit the code in the handle collision function. So it says here how collisions work. Not only can you trigger events by touching the scene, you can also trigger them when two sprites collide. So this is when our game starts to assume a little bit of a life of its own. And I hope this throws you back to some of the work you did when you built an aquarium app, or whatever app you built during those exercises, where we sort of faked our collisions. We figured out that if things were close enough by using that distance from function, that we said, okay, if they're close enough, then we should turn, or we should pretend like they crashed, or react to that somehow. Now, SpriteKit is going to do a lot of that for us, so it'll send us an event when two objects collide. So we're going to try running the code. We're going to notice how the pinball reacts to the different colored bumpers. And then we'll read the code to see why they reacted the way they did. Then step three, we are going to use the angle xdir to enforce the collision.force, the collision to keep the pinball in motion longer. The goal with this game is going to be to see how long we can keep our pinball in motion. And then we're going to need to fill in our own code for when the spring and the pinball collide. So here's our function. We have a handle collision function. And if we go way down to the bottom, if we skip the body of that for now, we can see the scene has a set on collision handler method. and we assign that function that we defined as our onHandler collision. So anytime there's a collision, this function will get called. And the page difficulty set to medium. So if we look back up here, we have these two names that come in. So we have a parameter passed in called collision that's of type collision. And we have sprite A and sprite B. Those are the names of the two sprites that collided. We calculate an X direction and a Y direction. We'll get into that in a sec. And then we have this big chunk here where there are a bunch of if statements where we say, hey, if names contains ball and names contains green bumper, then we run a bit of code. So this names property is an array, because you see that from the square brackets. And you might remember we can access items in the array by doing something like this. We could do something like names and then do a square bracket and then a 0 to access the first item in the array. But arrays are used for all sorts of things. We store loads of things in there. And just like if you stored things in a drawer, you need to sometimes go in and look for the items that you stored in the drawer. This contains is a great method on an array where you can ask it, hey, do you contain an item in there called ball, or do you contain an item in there called green bumper? Now we only have 2 items in this array. So really what that means is, for this to be true, sprite A needs to be called ball or green bumper, and then sprite B needs to be called the other. So it needs to be called ball or green bumper, whichever one wasn't the first item. Let's check this out. Let's run our code and see what this looks like, and then we'll go through some of the other items. So here's my pinball down at the bottom. I'm in practice mode. I could hit play to go play the game, but I'm going to tap on the pinball. I can drag it around, and gravity is turned on in the scene. So if I drop it, it's going to bounce off those other objects. So let's try bouncing it off a green bumper. Okay, so when it hit the green bumper, what happened was the pinball, which is this guy, was applied. We applied an impulse to that of 80 and on the x-axis and 80 on the y-axis. Well, now we're going to play with these numbers to see if we can get it to change. And then we incremented the score for every time we collided. So we were able to get more points that way. We want to make sure that we do that every time 2 things collide here. Okay, so that's the green bumper. Let's check out the pink bumper. So when the ball and the pink bumper collide, we're going to apply an impulse of xdir times the collision force times 5. And then the y direction will be the same thing, except with the y-dir. So we'll do y direction times the collision force times 5. Okay, well, what's the x-dir and the y-dir? Well, for our collision parameter that gets passed in, we have a property called angle. And so the angle is going to be a combo of the direction y that it's coming down and the direction x that it's coming at the thing it collided with. So it sort of tells us if it collided with it on an edge, straight on, over to the side, from the bottom. We'll get an idea of how this ball actually hit our object, so we can tell which way we should send it off so that it actually looks like it would in the real world. So let's try dropping this ball off a pink bumper. Okay, that's a much bigger bounce off the pink bumpers. Okay, so that's a pink bumper. The last thing we have here are these springs. So let's go take a look at the code we use for springs. So when the names contain an item called ball and an item called spring, we just use this spring animation. So we got to write a bit of code here. Probably something like this, where we want to apply an impulse to our pinball. So let's try dropping it on a spring. So I'll bring my finger up. Okay. We see the spring animation. The spring pops out. So we'll want to write some code to apply an impulse. Now, I personally think that looks a bit stronger than our pink bumper. So maybe we would want to have that apply a bit more force. You can also see that the more you bang against them, they start to fade out. So we only have so many times we can bounce off these items before they disappear. All right, and then the last thing here is this: if name contains ball and name contains end game, then we end the game. There's an end game function we call to end it all. That's defined somewhere else. All right, well, let's try writing some code. Let's first write some code to apply an impulse when we hit the spring, and then we'll increment the score as well. Or actually, maybe we won't increment the score because we'll only increment it when we hit these, the bumpers. So let's see. What we'll do is delete those 2 lines I just created. I'm going to write my code right underneath the comment and above my spring animation. So let's see. We're going to do kind of like what we have up here. So let's do pinball, because we have a variable called pinball in here. So pinball, and we're going to use this apply impulse method on the pinball. We can also try apply force just to see what happens there. But let's start out with using the apply impulse. All right, so we have the direction we're coming at from our X dir and our Y dir. Let's try using this X dir, and instead of using the collision force, because maybe the spring will provide all the force, we'll try do X dir times maybe, let's do 10 for kicks, and then Y, we'll do the same thing. We'll do Y direction times 10. We're still practicing, we're still playing around with it. We're just writing some code to see what happens when we test it out. So let's hit run our code. Okay, there we go. Now we just wrote code for spring, so that's when we're interested in testing. So if we drop it, okay, maybe that's not enough, as it just kind of sticks there. So maybe we need to apply a force of 100 instead of just 10. Let's try that out. 100 on both axes. So let's run our code. Okay, we're back. You'll notice that even when I drag, when I'm dragging around the screen, you can see if I collide with something, it moves very quickly because that counts as a collision. So here, let's drop it from here. Okay, not super impressive. So maybe we do need to use the collision force, because that seems to be quite a bit higher than 100. So I'm going to do X direction times, we'll keep the times, we'll use the collision force property, and we can see, we can access the angle and the force, so we'll do force, and then we'll multiply that by 10. Put a little space there. So now we have our X direction multiplied by our collision force multiplied by 10. We'll delete our 100. We'll do the same thing here. We'll do collision dot force for our Y direction. We'll multiply that by 10. Now let's try running our code and see if this is a bit more impressive. Okay, here we go. Drag it up by the side. I'm going to drop it right onto the spring. Okay, that's a bit better. That looks more like a spring. All right, well, will we try playing the game? I mean, I like the way it behaves when it hits the pink bumper. Maybe the green bumpers are a little bit dull, but That's all right. We can tweak that in a sec. Let's hit play and see what we have. All right, so 3, 2, 1, here we go. Now if we hit this green button over here, it's gonna launch our pinball out into the bumpers and off we're gonna go. And this is the end game sprite that it hits where we actually end the game at the end. So let's hit that green button. There we go. Okay, cool. Those springs are doing their job. Pretty good. Oh, and we hit end game. All right, so we got a score of 20. Not bad, not bad. All right, we'll take a screenshot of that just in case that's our high score and that's as high as we're gonna get. Let's try this one again. Let's practice. Let's maybe change the green bumper to take a value. Maybe we'll do the same thing we've got below. I like using the force and the X direction and the Y direction because then it looks like a real pinball game. So we'll do xdir times collision.force. And remember, you want to make sure you get the collision with the lowercase c because that's the actual parameter that's passed in. The collision with a capital C is actually our type. So we're going to do collision.force just to get a number that we can multiply with something else. Times, so let's do this one. This is a double, so we can do 2.5. It won't be as bouncy as the pink bumper. And it definitely won't be as bouncy as the spring. So let's do our Y direction. Times collision dot force. And we'll do the same thing, 2.5. Not 2.t. All right, we'll hit run. All right, let's try it out and see what that green one looks like. Okay, not bad. And the nice thing is that if the ball is falling slowly, by using the collision.force, that changes whether the ball is falling fast or falling slow. As you can see, when it shot off of this one into that bumper, it went much faster than when it hit the previous pink bumper. All right, so let's try playing that again and see if we can't beat our previous score. Here we go. I'm going to press the green button again. Off we go. Ooh, way worse. All right, let's try that again. 3, 2, 1. There we go. Okay. Looking good. Oh man, 13. All right, well, 20 might be my high score. Let's check out the hint and see what other options we might have available here. Okay, so they're saying to make the green bumper act in a realistic way and keep it in motion longer, maybe we just want to use the force. So maybe we take off that multiplier so it doesn't bounce quite as much. So we're using the direction that it came in at from the X direction and the Y direction. And we're using the force. The reason why these are negative is because this dx is the angle that it's coming in at. We actually want to have the opposite of it because it's going to bounce up and away the opposite way. All right, so let's see the other hint. Okay, so at first the spring collision only runs an animation when hit. So this is where we added some code. So in this case, they multiply the xdir and the ydir by 100. And they don't use the collision force. So the spring always has the same force. So let's try, we'll change that in a second. Let's try running our code with our softer green bumper. Let's try again. Let's run our code. We're going to play. We'll hit the green button. Okay, that green is a bit softer now. Oh, I think I'm doing better here. I'm getting more on my way. Oh, still didn't get my high score. That is tough. All right, well, let's try changing the spring. We'll take away our collision dot force, and we'll just multiply the x dir by 100. And we'll do the same thing with y dir. We'll delete collision dot force. That won't come into it anymore. Now we're just following their example. If we wanted a game where we wanted the springs to be super responsive and also take into account the force at which the ball is hitting it, that's our prerogative, because this is our game that we're building here. All right, so we'll hit the green button, off we go. Okay, that's terrible. All right, so I'll tell you what, I'm actually just going to hit the undo key. And instead of doing by 10, we'll actually change this to use the collision force and also multiply by 100. So now in the spring and ball collision, we're taking into account the force and we're multiplying it by 100. So let's run our code and try that. I'm going to hit play. Hit the green button. Well, this is good. Looking good so far. Okay, that is crazy fast. All right, 15. Oh boy, I still haven't beaten my score. How high have you gotten so far? You can see this makes for a really interesting game though, and gives us a ton of possibilities for how our code might react if we were building a game and we wanted things to collide. So now if you're building an aquarium app, your fish could collide or avoid each other or turn around. They could use this angle that they're colliding at to turn around and go the opposite direction. They could also determine how fast one was going by using the force to say, okay, all right, they were going too fast. Maybe that's when they do collide. And we maybe use that scale method on some of our objects to scale them larger and then smaller. Loads of different things we can do with this collision stuff. So let's go on just briefly to the next page. So we did Bumper Bash. This is Gem Hunter. So now that we've done touch, light, sound, and collision, now we're going to look at all of them together to make a really interactive scene. So they are telling us that they've provided a bit of code, but it doesn't work particularly well. So now we need to edit the code to perform better in the game. And as you can see, we edited the code a little bit, and that was our best possible performance. And then we kept tweaking it, and we still never got quite back to our high score again. All right, so what we're going to do is experiment with different ways to use sound and light events to control our character. We have access to handle touch moved. And then we're going to change the if statements in the handle collision function to make them our own. All right, so for a bonus level, and we won't finish this one today, obviously, we'll work through this a bit tomorrow too. We're going to create labels to show the pitch, volume, brightness, and color data so we can see what all of our sensors are telling us. Now we can also, as an extra bonus, we can also display information about the touch events that we get on the screen, or the collision events that we see. Maybe we can capture some of that and show it in a label so that we can actually feel and figure out more about the physics of this game. All right, so before we get into that, there's actually some great resources out there. If you search for game or physics for game developers, you'll find a lot about how to make your games a little bit more realistic and use some of the built-in physics functionality, especially in a framework like SceneKit, which is Apple's 3D game framework, or SpriteKit, which is their 2D game framework. All right, so let's try running this. Now the code is here. We've got our tone sensor, and we place the player at this start point, which is predefined somewhere. We have this handle tone update, where if the tone volume is greater than half, the player gets an impulse of 600 up. We have a handle touch moved function, where we take the X direction from the where we touched X position and then the player's X position. It takes the difference between those two, and then we have the player dash at that speed. We have the handle collision function, where we have our names array, and we have a player, so we have a spring, so we're going to have a spring pop in there, and then we apply an impulse of 400 on the y-axis for our player. If the names contain spikes, we play a sound, and we end the game. And if the names contain gem, we remove the gem for a particular collision, and then we increment our score. So this is an interesting way. So before, if we look on the previous page, in our handle collision handler, we did a check for 2 values in every single if condition. We said if the names contains ball and the names contains green bumper, then we'll do some code. Same thing here. We had a check for ball, check for pink bumper. And then here we had a check for ball spring. And here we had a check for ball and end game. The code was written a little bit differently in this other handle collision handler, because first there's an outer check. We say, okay, if the names contains player, excellent, that we know that we want to do something because the player has collided with something, whether it's a spring, spike, or a gem. And then we had separate if conditions nested inside our outer one. So this is a really handy way to write our code, because we only check for whether or not the names contains player once, and then we check that array for the spring and spikes and gem names the next time, if there's a player in there already. So that's kind of a good way to write our code. And then we have some more code down here after our handle collision handler. We set the on update handler on our tone sensor to be our handle tone update function that we have up above. And on the scene, we set the on touch moved handler and the on collision handler to our other functions we have here too. So let's start running our code and checking it out. All right, so let's practice to start off and see how this behaves. So we hit practice. As I'm talking, you can see our giraffe jumps anytime I talk loud enough. Now if I tap on the screen, I'm going to tap about here on top of this gem here. And we're going to see what happens, see how that giraffe moves. So we'll tap. Nope, halfway there. Tap again. Tap again. Oh, cool, we got 1 gem. That's pretty good. Maybe we'll tap over here. Tap over here. Oh, we're close. Oh, there we go. Now we have to talk and get our giraffe over. It's going to be hard getting around those spikes. So here we go. We'll start talking again. And talk again. Okay, so it's just if we land on the spikes, I guess, that we're going to have problems with the spikes. So we'll talk a little bit louder. We'll talk again. We'll use our little handy thing down there. Oh, there we go. We got another gem. Another gem. Oh. Cool. This is great, playing video games. So if we keep talking and we try to get this gem, looks kind of interesting down here. That's where we're going to end our game. Okay, so right now the spikes isn't ending the game because we're just practicing. But let's try playing a game and see how this works out. Okay, so if we start talking, oh, and we actually have a timer, so that's tough. So here there we go, we got one. We don't want to talk too much. That's cool, there we go. If we talk a bunch more, we get rocketed way up to the top. Remember, we're using that X and Y, X axis on our touch position to move the giraffe over. Oh. All right, well, we got a 9. That's not too bad. Better than I thought we were going to get, that's for sure. All right, so how would we improve this, do you think? So we have our pop. I'm going to reset this so we get our hints back, because let's take a look at the hints and see what they think we could do here. So there isn't a function for light. That's a good one. So it's just about time up for us. So what I'd like you to try is keep playing around with this game. I'd love to see if you could make a game where you can collect all the gems and you can use the light sensor in certain ways. Maybe the giraffe shrinks down and makes it easier to get through certain holes. Maybe it keeps them floating in the air for a bit longer. At any rate, I'd love to see, or maybe it moves them directly to certain positions. It looks for gems and it moves them to certain positions. I'd love to see what you can come up with. We're going to be playing around with this a little bit more tomorrow to build a really awesome game. So, happy coding. Make sure you like and subscribe to the channel. That would be awesome. And we'll see you tomorrow.